So by now you've watched a few videos of the unit circle and how to find those different points in the unit circle. After watching the Better Explained video, hopefully we remember that this is theta and that there's a point x and y on that unit circle. This radius from the origin to the outside edge of the circle, that is always going to be 1. And when we are talking about this, the distance from this point on the unit circle down, that represents the screen as if it was hanging on the wall, or it is the y value, which also represents the sine of theta. And the bottom, or the distance from the origin to the screen, that is your x value or your cosine of theta. So what we have here is the start of that definition is the sine of theta is always going to equal the y value on the unit circle. The cosine of theta will always equal the x. And the tangent of theta will always equal y over x. Now a few more definitions that we have. We have the cosecant, which is abbreviated as the CSC, or the cosecant. That is of theta. That is always going to equal 1 over the sine of theta, so that is equal to 1 over y. Now, the secant, or that is abbreviated as SEC of theta, that is equal to 1 over the cosine of theta, or 1 over x. And the last one is the cotangent, which is abbreviated as COT of theta. That is equal to 1 over the tangent of theta, which becomes x over y. These are just the definitions. Please make sure you've watched the Better Explained video posted earlier in 4.2. It will really help you understand what's going on with these. Now, how do we use all of this? So the way we use all of this is if you are given a point on the unit circle that is the square root of 3 over 2 and 1/2, we do know that this angle, if I wanted it, was pi over 6, or 30 degrees. So what that tells me here is I know that the sine of theta, or the sine of pi over 6, is equal to the y value, which is equal to 1/2. The cosine of, and I can use either number here, 30 degrees, although most of the time in class we will stick with radians. The cosine is equal to x, so that is just equal to the square root of 3 over 2. The tangent of pi over 6 is equal to y over x, so that is equal to 1/2 divided by the square root of 3 over 2. Now, when you're dealing with complex fractions, this is really just saying 1/2 divided by the square root of 3 over 2, which turns into 1/2. That becomes times 2 over the square root of 3. The 1/2s cancel. and you are left with 1 over the square root of 3. But we have to rationalize that. The way you rationalize is you multiply the numerator and the denominator by exactly the same value. So that leaves us with the square root of 3 over the square root of 9, or square root of 3 over 3. So that would be the value of the tangent of pi over 6. Now, to do the reciprocal functions of all of those, we just go ahead and flip them. So to find the cosecant of pi over 6, that is, again, remember that is 1 over the sine, so that becomes 1 over 1/2. Again, just flip that. That's 1 divided by 1/2, or 1 times 2. So all of that just equals 2. The secant of theta is equal to 1 over x. Therefore, the secant of pi over 6 is equal to 1 over the square root of 3 over 2. And again, we're just flipping that fraction. That's 1 divided by the square root of 3 over 2, or 1 times 2 over the square root of 3. But we do have to rationalize that, so that means we have to multiply that by the top and the bottom of the square root of 3 over the square root of 3, and all of that is equal to, so that means that the secant of pi over 6, 2 square root of 3 over 3. And the last one is the cotangent, and the cotangent of any angle is just equal to x over y. So therefore the cotangent of pi over 6 is equal to x is the square root of 3 over 2 divided by 1/2. And those 1/2 do cancel out the way they did before, but I will go ahead and write it out. That's the square root of 3 over 2 divided by 1/2, or I multiply times the reciprocal, which is 2 over 1, which is why all of those cancels, and that is just equal to the square root of 3. No need to rationalize this one.